We're talking instantaneous velocity. The magnitude of instantaneous velocity is instantaneous speed. But average velocity, the magnitude of average velocity is not necessarily, and usually not, the average speed.
So 1.6 miles? No. Way up.
It's going to be some unit of distance divided by some unit of time.
So would it be 40 miles divided by what? How many hours there is in a day?
No, you don't. We can keep it in days. That's not an issue there.
40 over 30? No.
Not 40 over 30. What do you suppose the formula is for speed, for average speed? Average speed is distance divided by time. What was the distance traveled?
2,000.
So my average speed, distance divided by time, which is 2,000 miles, divided by 50 days. Without a calculator, come on.
400.
There we go. That almost sounded like the chorus of angels that I liked. That was nice. Or you have an incredibly powerful voice that just sounds like many people. 400 miles per day. No vector. There's no direction involved. Now, if I had just gone straight from Columbia up to there, let's clean this board up some. So I'm starting here, Columbia, got Winston-Salem, and I just travel straight, 200 miles. And I do it in 4 hours. What is my average velocity? Oh, again, gotta define something. There we go.
It'll be 200 miles over 4 hours, which is 50. Probably divide that. 50 miles per hour.
Thank you. Now, units are incredibly important here, and just to let you know, if you had just answered 50 and left it at that on a quiz or test, you would have gotten 4 out of 10 points. You would have lost 3 points for not having units and 3 points for not having a direction. Just, it matters to me. What is my average speed?
50 miles per hour.
So here's a situation in which the average speed is the magnitude of the average velocity, but obviously in the previous case, did not happen. I believe in the video I talk about how I'm as fast as Usain Bolt, using physics and definitions to make me seem faster than I am. Make sure this is still going. Sometimes this thing just likes to stop. Put our origin back here again. I'm going to make it to the right, positive. All right, my starting point is still over there in green. So my position, displacement, velocity,
0.
that's what I'm going for, relative to either the origin or the starting point. I'm not going anywhere. All right, my velocity,
Negative.
my position,
Negative.
my displacement,
Negative.
my velocity,
Positive.
displacement,
Negative. 0.
Position.
Negative.
Okay. Questions on how people are coming up with positive, negative, 0? limits it to 1 that people have the most trouble with. Acceleration. The symbol A, it's a vector symbol. Just to get it out of the way, I think I mentioned this last time, the scalar word is also acceleration, and it is A without a vector symbol. What is acceleration?
Rate of change of velocity.
Say it again?
Rate of change of velocity.
Oh, yep. Rate of change of velocity. We can be slightly more specific and accurate if we said the time rate of change. That's just a fancy way of saying that acceleration is the change in velocity over the change in time. And this acceleration is the change in speed over the change in time. So, in order for there to be acceleration, there has to be a change in velocity. So when you're driving a car, let's assume automatic transmission, just to simplify it. What are the 3 accelerators that you have access to as a driver?
Gas pedal.
There's 1.
Brake pedal.
There's 2. What's that?
E-brake?
I'm lumping that in with the brakes, all the brakes together. Neutral. So somebody else, we have gas pedal, we have brake.
Neutral.
Neutral doesn't, how does that change velocity? Pardon?
Reverse.
Park.
But in order to reverse, you still need the gas pedal.
Clutch.
What'd you say?
Clutch.
No, automatic transmission?
The steering wheel?
Yes. Why?
Because doesn't it involve the direction as well?
Velocity is speed in a direction. So if I change the speed, gas pedal or brake, or if I change the direction, steering wheel, I am accelerating. Now this will come in incredibly important later on when we get to chapter 4 especially, is that if there is acceleration, there has to be a net force. And so basically once we get through the definitions of motion here, we start getting into the force analysis, and that becomes a major part of physics. All right, so as we're doing the plus minus 0, or let's go ahead and throw a couple of notes up here. So position is 0, so it's positive if on plus side of origin. Displacement is positive if on plus side of starting point. Velocity is positive if moving in positive direction. And then the negatives, just replace the plus with minuses and it still works. Now, acceleration deals with the change in velocity. The only 2 vectors in this equation are acceleration and this v right here. So there must be a change in velocity for there to be acceleration. So if you were moving at 50 miles per hour north, and you have it on cruise control, an excellent cruise control, flat ground, you're following great, you have perfectly aligned tires, you fall asleep, the car just keeps going straight. There's no acceleration. There are so many times I've seen students write acceleration is 0 when the velocity is 0. No. Here is a quick example of acceleration being zero, not zero, what the velocity is. When I let go, how fast was the ball going?
Negative 9.8. No.
How fast? Thank you. It wasn't moving. But it started to move. And it had to accelerate. If my velocity changes, there must be acceleration. If when I let go, the acceleration was zero, that ball would have just stayed hovering there. Because the velocity was zero. If acceleration is zero, it means the velocity doesn't change. And so it would just stay there. And not the way reality works. Otherwise, as a kid, anytime you jumped in the air, you would never come back down. Okay. So acceleration deals with change in velocity. So right now, my velocity, positive, negative, or zero? My velocity.
Negative.
Thank you. Now my velocity,
Negative.
all right, so my velocity was a slow speed that went to a higher speed. So I start out with a low velocity, so a negative, small, let's just say negative 1 meter per second. And then I go to negative 3 meters per second. My acceleration, positive, negative, or zero? Or? There we go, yeah. This is probably one of the biggest mistakes that I keep seeing again and again. Speeding up is not automatically positive acceleration because you are so used to dealing with this acceleration where speeding up would be positive, but we are talking about the vector acceleration. If my initial velocity is negative 1 meter per second and my final velocity is negative 3 meters per second, what is the change in velocity?
Negative 3 minus negative 1, which is negative 2, I think. Yeah.
My change in velocity is negative, therefore my acceleration has to be negative. So acceleration is positive if the change in velocity is positive. And that could mean, if my initial velocity, and let's go for something brighter, my initial velocity, if it's 1 meter per second and I go to 3 meters per second, that's a positive change. I sped up. If my initial velocity is negative 5 meters per second and I go to negative 1 meters per second, what is my change in velocity?
4 meters per second.
Here my change in velocity is positive, I sped up. Here my change in velocity is positive, I slowed down. Now, it turns out if the change is the same sign as the velocity, so if my velocity is positive and my change is positive, I will speed up. If my velocity is negative and the change is negative, I will speed up, just in the negative direction. If they are opposite signs, so here my velocity is negative and the change is positive, if they're opposite signs, I'm going to slow down. Connecting this with force, I'm going to jump ahead a couple chapters here just to introduce Newton's second law of motion, what I consider the most important equation in physics. It is saying that the net force, this is the total force, is proportional to the acceleration. They're the only two vectors in that equation. Force and acceleration have to have the same direction. So if I'm walking in the negative direction, someone pushes me in the direction I'm moving, will I speed up or slow down? If I'm walking in the positive direction and someone pushes me in that direction, will I speed up or slow down?
Slow down.
So if the force and the motion are in opposite directions, you will slow down. Same direction, you will speed up. All right, so let me stick my origin back. And find positive to the right. All right, you have to be a little bit faster here because I got 4 things to deal with. Position, displacement, velocity,
Zero.
acceleration.
Zero.
All right. Oh, reserve. It's not 0?
It is.
Okay. All right, now I start to move. At that moment that I'm starting to move that way, my acceleration,
Negative.
yep, I go from 0 to a negative velocity, so that's a negative change. And by the way, change, there are not many things in physics where you can get away with always. This is one of them. Change is always final minus initial. Despite what some students are trying to convince me on the test. Change in velocity is final velocity minus initial velocity. The amount of money you make in a day is the money you have at the end of the day minus the money that you had at the beginning of the day. Velocity,
Negative.
when I come to a stop, my acceleration. I'm now at my velocity.
Positive.
When I come to a stop,
Negative.
I think you're ready for the next part. Questions?
Can you explain that, what you just did right there?
All right, so my velocity was negative
Yeah.
here, the first part, and I come to a stop. So my velocity goes from some negative number to 0. If you think about it on a number line, think of the classic number line, 0, we got positive numbers here, negative numbers there. I'm going from a negative number to 0. I'm going in the positive direction. So my acceleration is positive. When I was going in the positive direction and then stopped, I'm at some positive velocity, and then I go to 0, it's a negative change. Is that sufficient?
Yeah.
Oh, before I erase more of this. Again, acceleration, there are 2 types. There's instantaneous and average. Default, instantaneous. If I want the average value, I will have to specify average. A ball is going to be thrown into the air. Other questions before I start on this next bit? All right, a ball is going to be thrown into the air. It's going to go up and down, just so we're all on the same page. Let's make up positive. I know I have it spread apart slightly in the horizontal direction, but just assume it goes straight up and down. This is just for viewing purposes. Otherwise, it would just be, it would look like that. It's difficult to tell what's going on. I'm going to define 4 moments in time. A is the first moment in time. This is just after the ball leaves the hand. B, the moment the ball is at the peak. C, the moment the ball is in the same position as it was at time A. Just going down. And D, the moment just before the ball touches the ground. So this is the duration of the problem, and I would label the problem, given this, A, B, C, and D. And I would like you to take 5 minutes, and feel free to work with the person next to you, to figure out we have position, displacement, velocity, and acceleration. When is it positive, 0, and negative, or when is each? Now, in terms of notation, I'm going to present several different notations here. And with a class this size, on the first test, when you have a problem similar to this, there'll be at least one person using each notation, so like. Taking from the math, if an object is, let's say, position, I need to do one other thing for you to figure out position. Just so we're all on the same page, we'll make the ground is 0. So if something happens starting at time A, including A, and goes up and goes almost to C, but not at C. So if you would write A, C, and so this is, that's the shorthand for from A to C, including A, excluding C.